Hey guys, let's pick up here where we left off in class on Friday, where we were talking about adding linear expressions. Linear expressions, of course, being that the variables have no exponents on them. And adding linear expressions basically has us just combining like terms. So when you have some group of variable and constant terms and you add another expression of variable and constant terms, you combine the like terms. Okay, so x plus 2x here combined together to give you 3x, and 5 plus 3 combined together to give you 8. So the answer here is 3x plus 8. And again, you cannot combine these together, the 3x and the 8, because they are not like terms. Variables, okay, if 3 of them, you cannot add with constant terms. So sometimes you might look at the models of these in the book where you have 4 negative x's and you have 5 negative x's, and when you add them together, you end up with 9 negative x's, and 3 plus 2 is 5. When you add a positive and a negative, they're going to cancel each other out with 0 pairs if you were to add these with counters or algebra tiles. And this one's going to give you negative 2x plus x is negative 1x, and 6 minus 4, 6 plus negative 4 is 2. So negative x plus 2, we don't write the invisible 1 there. You can if you want to, just not stylish. And number 4, negative 7x plus x is negative 6x's plus 6. Again, you can use the tricks of dots underneath, or you can use different shapes to identify the like terms. Really hope that you really don't need to do that after too much time, and that you can just go right to writing the answer. If you have a shape that gives you algebraic expressions as the lengths of sides of a shape, you can add those expressions together to get the perimeter. So the linear expression for the perimeter of this figure is x plus 5 plus 2x minus 2 plus 2x, adding all of the sides together. You could put them in parentheses if you wanted to, right? Just for clarification of what goes where, right? So you can put parentheses here, x plus 5, and then plus 2x, and then minus 2. I'm sorry, 2x minus 2. And then finally 2x. Okay, all these parentheses, none of these are required to give you the correct answer. They just group the different sides of the shape together. Okay, they don't affect combining like terms at all. Combine all the x's together. X plus 2x plus 2x is 1, 2, 3, 4, 5, 6 x's plus 5 minus 2 is 3. So this is the simplified expression. And then what is the perimeter if x equals 4? So there'll be a number to substitute in there. Put a 4 in here for x. If you put it into each of these separate ones and you add these all together, you'd get the same as if you put 4 into the simplified expression. 6 times 4 plus 3, and that's 27. Okay, so that's adding linear expressions. So, like we do with lots of things, when we look at subtracting, subtracting gets a little bit tricky because of having to take away things. Not so easy to model. Okay, so what we're going to do, so here it says when subtracting linear expressions, subtract like terms. All right, I really don't like this plan, okay, the subtracting like terms, because subtracting messes you up when you're talking about positive and negative numbers. Okay, so yeah, if it's all positives like this example, 5x plus 4 minus 3x plus 2, you're taking away from 5x plus 4. And so they show you with the model. Okay, so take away 3 of the x's and take away 2 of the constants, and you're left with 2x's plus 2, okay? But you're not going to draw these out, right? And if some of these are positive and negative, like the next example, this gets pretty unwieldy and confusing. Can be, okay? So we're going to do the same thing that we do when we add and subtract positive, or when we subtract positive and negative numbers. And that same thing is same, change, change. That's how we're going to subtract these expressions also. So instead of 5x plus 4 minus 3x plus 2, we're going to change this to 5x plus 4 plus, we're going to change everything on this in the second expression to its opposite. Okay, so instead of minus 3x plus 2, that's really the same as plus. We've changed the subtraction to plus, and then changed all of the terms in the second expression to its opposite, and then add them together. 5 plus negative 2, or negative 3 rather, is 2 x's, and 4 plus negative 2 is 2. Okay, so this is the method that's used later on when these things get more complicated. Again, if it's all positives, just like you didn't have to do same, change, change for a second grade subtraction, if it's all positives, you can subtract 5x minus 3x, 4 minus 2. But when these things start getting to be positive and negative numbers, it's very easy to mess this up, the subtraction part, the second expression. So same change, like in this example, right? In example B. So same change, change is really the best way to handle these problems, okay? So they, they again change this. You can see here, they arrange the like terms in columns, and then each term is subtracted, and subtracted is the same as adding the opposite. All right, you should be able to, in my opinion, just type it out yourself or write it out. So this one is negative 4x minus 6, and instead of subtracting, I'm going to change the subtraction to addition and change the things inside the second expression, which will be in parentheses, okay, has to be in parentheses. These change to their opposite. So it was negative x minus 3 or negative x plus negative 3. Now it's just x plus 3, okay? So this again is same, put that in here, same, change, change. Same, change, change. Keep the first expression, change the subtraction to addition, change all of the terms in the second expression to their opposites, and then add. So this is going to give you negative 3x, negative 4x plus x, and plus negative 3, which stylishly you will write as negative 3x minus 3. Okay, so go ahead and try these two on your own. 7x minus 5 minus 2x minus 1. Same change, change. 7x minus 5. So this writing it like this is really a way to say, okay, we're going to change the signs of both sides over here. You really could just write it directly like this second line. Every term in the second expression changes to its opposite. So this is 5x plus negative 4, right? This is plus negative 5. I could have written it as plus negative 5. Negative 5 plus 1 is negative 4, stylishly written as minus 4. And 1b. Change, same, change the subtraction to addition, change both of these to their opposites. So this becomes negative 2x, this becomes plus 4. combine your like terms now. So 6x and negative 2x is 4x, and negative 4 plus 4 is 0. So I don't have to write that, 4x plus 0, just 4x. All right, the book then goes to word problems or real world problems with linear expressions. And this basically is just stuffing these algebraic expressions into a real world problem. There's no real application for when you would use this right now. It's just setting you up for future problems where you can solve real world problems algebraically. Here it seems kind of silly. Like, who says 8x plus 48.75 is the total amount of money the soccer team earns? Like, where would that come from? Okay. But it's okay. You should be able to still interpret the words and make them into an addition, which we talked about on Friday, or subtraction, just subtracting or adding linear expressions, algebraic expressions, instead of numbers. Not that big a deal. I won't spend too much time on these, but you will see a couple of these examples in the practice problems. All right, so that's it. Now we'll give you some practice problems on adding linear expressions and subtracting linear expressions, and that'll be good before we get together and go to the next step here in the next class. There you go.